Okay, so in this video I am going to talk to you about Pythagoras. I'm going to give you a wee bit of history and I'm going to show you a couple of different ways that I would use in front of the class if I was introducing this for the first time. And I know some of you will be watching this and not being able to take part in an investigation as such, but just to let you see how I would try and get pupils to discover it themselves. So Pythagoras, we're going to learn Pythagoras' theorem and how to find sides in a right angle triangle. So Pythagoras was a famous Greek mathematician. He discovered the amazing connection between three sides of any right angle triangle. The connection which connects the three sides means it's possible to calculate the length of any one of the other sides in the right angle triangle as long as you know two of them. And this is a skill you will use if you go into any kind of trade, okay? Anything to do with measurement and things, you will use Pythagoras. So, right angle triangles. The aim is we're going to investigate the right angle triangle and come up with a relationship between the lengths of its two short sides and the longest. Now, the longest side is your slope. It's called your hypotenuse, and that's always the one across from your right angle. The one that in all my diagrams is labelled with a C. So, having a look at this first triangle, what is the length of A? And you'll be able to get that just by counting boxes. So, the length of A is 3. And the length of B is 4. And then I would get you to get out your rulers and measure the side of C, and it works out to be exactly 5, okay? 5 centimetres this would be, okay? So that's called our 3, 4, 5 triangle. Then I would get you to look at this right angle triangle, and looking at the bottom, our A this time is 6, our B this time is 8, and our C this time, if you brought out a ruler and measured it, would be 10. And then I would get you to draw one more triangle on your jotters and would look at this one and would say, right, okay, the side of A is 5 boxes, B is 12 boxes, 12 centimetres, and then I would get you to measure side C, and that on your ruler would come out as 13 centimetres. Then what I'd do is I'd get you to draw out this table and would put in our triangles here. So this was our first triangle, this was our second one, and this was our third one. So remember, C is always your hypotenuse, your longest side. Now, then I would leave that in front of you and I'd ask you to fill in the table, and we'd fill in these numbers. And it would give us this. And then I would just leave it on the screen or in your jotters a while and ask you to try and see if you could spot a relationship between A squared, B squared, and C squared. You might spot it straight away, you might not. In the lead up to this in class, I would quite often get you to do sums like 3 squared plus 4 squared, or sums like 10 squared take away 8 squared. And that would have been in your starters for a couple of days leading up to Pythagoras to try and lead you into this as well. Hopefully, if you look at it, the connection is, if you do A, you square it and you get 9. If you do B, you square it and you get 16. If you then add these two together, so if you do 9 plus 16, you get 25. Then I'll get you to say, right, okay, square your first number of 5, that gives you 25. Square your second number of 12, gives you 144. When you add them together, you get 169. Now, going on having prior knowledge of square and square numbers, what is the square root of 25? Oh, that gives us 5. And I'd say, what is the square root of 169? Oh, that gave us 13. And then I would try to get to come up with a wee formula. And the formula would be, right, well, we got our first number. Our first number was A, and then we squared it. Then we got our second number, which was B, and we squared it. And when we added them together, we got what C was when it was squared. And that is your introduction to Pythagoras' theorem. That's the formula. I'm going to show you another proof as well that we sometimes use in class. So we start with the same right angle triangle, A, B, C. C is always our hypotenuse. Now it could be any old letters, but these probably are the most common ones. Then on each side we would draw a square. Now it doesn't matter what this square is, what the dimensions of A, B and C are. This would work for all of them, but I'm going to stick with that 3, 4, 5 triangle. So we're going to say that A was 4, B was 3, and C was 5. And if you look very closely, there's the 9 boxes for B. So that was your 3 squared was 9. That's in the blue. And then this one would be your 4 squared, which is 16. And if you look very closely at the C, There is your 9 blue boxes. And then there is your 16 yellow boxes. So your 3 squared plus your 4 squared is exactly the same as this side, which was 5, which was that squared. And that was the connection that Pythagoras established. Okay, so what we're going to do is, this is a bit where I would ask you to start copying down these examples into your notes. So for any right angled triangle, the hypotenuse is the longest side. It's also the longest word, probably that you've learned in maths for a wee while. It's always the one straight across the right angle, and it's always the one it's normally your slope, but sometimes if that triangle is spun around, it doesn't look like your slope. And here is the formula we're going to use. C squared equals A squared plus B squared. However, I don't always get students to copy down the formula purely because I find that we can get confused with the letters and it's not hugely important to write it down. Okay, and we're going to start by just focusing on finding the hypotenuse just now, the longer side. It'll come later that we then do short sides as well. So here's my first example. So we call this long side C. I'm just going to call it X. So my working for this would be X squared equals, you take the other 2 sides and it doesn't matter which order you take them in, I just work left from right. So we do 5 squared plus 12 squared. Now you can actually, you're allowed a calculator here normally, but this one are numbers that work out nicely, and these are numbers we should know, okay? 5 squared is 25, 12 squared is 144. When you get them and add them together, that gives you 169. Now, that doesn't mean that our slope is 169, that means that our slope squared is 169, and you should know, hopefully, that the square root of 169 is exactly 13. And remember the theorem was that we take this number, we square it, we take that number, we square it, and that equals that number squared. So if we have a number squared, the opposite of squaring is taking the square root. Okay, so if it's a non-calculated example, I get you to do this line here. But if it's a question where I've said you can use a calculator, I don't get you to do that line. So we can shorten it down to 4 lines of working. Right, example 2, we need a calculator this one. So let's call our slope X. You can call it whatever letter you want, but I stick with X. So X squared equals 9 squared plus 5 squared. So X squared equals 81 plus 25 is 106. Now, that's not an exact answer this time, so we're going to have to go to a calculator. So something squared is 106. You do the opposite of squaring, and you do the square root of 106. And it won't be a nice answer, so you have to choose what your rounding would be. Do you do it to 1 decimal place? Do you do it to 2 decimal places? I quite like 2, because we always have to practice rounding to 2 decimal places anyway. And to 2 decimal places, this gives you 10 point. Now it's 295, so that will go up to 10.30 centimetres. And I always write the side that I'm doing it to 2 decimal places. Okay, so the side of that triangle is 10.30. And the reason I write it to 2 decimal places is that lets you know that, or whoever's looking at your answers, that wasn't exact. It wasn't exactly 10.3. Okay. Third example, let's look at this one. So our unknown side, X squared equals, take your other 2 sides and square them and add them. So 10.5 squared plus 7 squared. X squared equals, go straight to your calculator and work that out, which I'm doing just now. Which gives us 159.25. Do not dare round that, keep it exact, okay? And then we're going to do the square root of that number. And again, to 2 decimal places, that will be 12.619, so 12.62 centimetres. To 2 decimal places. Okay, so what I'd like to do now is go try these 8 examples for yourself. The first 4 will all give you exact answers, and the second row will give you decimals, and I'd like you to do them to 2 decimal places, so that will match the answers I have in the next slide. Okay, so give them a try, and good luck with them. So I would pause the video now, try your questions, and then press play again to check your answers. Thanks very much.